The Data Engineering Show is brought to you by FIREBOLT, the cloud data warehouse for low latency analytics. Get $200 credits and start your free trial at firebolt.io.
Hi, everyone, and welcome back to the Data Engineering Show. Today, we're super happy to have Chad joining us. Chad is the CEO and co-founder of Gable AI, which is a data change management platform. Chad, how about you just quickly introduce yourself, tell us what you're doing, tell us what Gable is all about. We're super excited to hear more.
Sure. Well, first of all, thanks for having me on the show, guys. My name is Chad. I live in Seattle. I've been in the data engineering and infrastructure space for a pretty long time, well over a decade. As you said, right now I'm the CEO of a company called Gable AI. We do code scanning. We essentially scan application code, figure out what data is being produced from those application systems, trace where data is flowing within a code base, and ultimately where it lands. We run during CI/CD, detect when changes are happening that could affect the data in some way, and we communicate the impact of those changes bidirectionally before they reach production. So that is ultimately what Gable is about. There's a lot more complexity to it, how we layer on data contracts or data governance as code, how you kind of start to shift data management to the left. Lots of really fun things that hopefully we're going to get into more today.
Awesome. Sounds great. So before we dig into what Gable is actually all about, and I think you're the first vendor we have in the show for a while, so I always love these episodes with vendors. Maybe give us a bit of background, right? What did you do before Gable? What motivated you to start the company? What sparked the idea to start this and get this going?
Yeah, I mean, like I said before, I spent a long time in data infrastructure. Originally, I was a data scientist. I was always more interested in the infrastructure side of things, so I moved into data engineering. But then I realized that as a data engineer, it was pretty challenging to launch the large-scale projects that I thought needed to happen in order to change the way that companies thought about data, use data culturally. And then I moved more onto the infrastructure side, so the actual buildings of the systems themselves. And I did that at some large companies, Sephora, Subway, Oracle. I was a tech lead on the AI platform team at Microsoft. And then I owned all of the data platform and AI platform at a late stage startup called Convoy. And really, everywhere that I went, I kept running into the same set of challenges, which is no matter how good our data quality posture was, no matter how thoughtful we were being about data governance and data usage, no matter how much time we spent sort of building out metric layers and systems to, grant certain access rights to particular engineers for certain things, the quality would always degrade over time. Governance would always degrade over time. And the reason was because there's two sides to what we've started calling the data supply chain. There's the first mile and the last mile. The last mile is everything that's happening after data lands in a warehouse and is transformed, and you use something like dbt and spin up data models and build dashboards on top of it. The first mile is everything that happens from the source to effectively cloud storage in most cases. And we were applying all of our quality checks, all of our governance, all of our best practices on the last mile, and none of it was being applied to the first mile. And because that's where all the sources were, that's where all the changes were happening, obviously you would incur exponentially more data quality issues over time without those guardrails in place.
Okay, gotcha. And then enter Gable, which is all about data contracts, data change management. Can you give us basically a 1-minute rundown of what I would use Gable for in my data pipeline?
Sure. So Gable does three things very well. The first thing that it does is we identify what are the places in code that data is being produced, who are the owners of those codes, so who's the software engineers actually responsible for generating the data and making changes to it over time. And what does it mean semantically? And meaning can be extracted by looking at the context of the code and documentation and things like that. That's sort of layer one. Layer two is if you can do that in many different technologies and many different repos, you effectively have multiple nodes in a graph. you can string that graph together and understand the directionality of data flow. So how does data move from that source system ultimately, into a database, through a Kafka topic, into cloud storage, and then to a data warehouse? And how is it transformed along the way? The big problem, or one of the very large problems now, is not that a data scientist or a data engineer can't go into a repo and code and subscribe to that GitHub repo and then get alerts if it changes. It's that, a data scientist might speak the language of SQL, a software engineer might speak the language of Java. So there is no translation layer in between, helping each side understanding the context of A, how sources change, and then B, how data consumers might want to use data in new and interesting ways. So that's the second thing we do. And then the third thing we do, we call data governance as code. So how do you establish the policies about how data should be treated, how it should evolve over time, what the expectations and SLAs are, and then translate those expectations into enforceable integration tests running in the code base. That's the data contract, and those are sort of the three things that the Gable does.
Okay, gotcha. So one thing I saw when scrolling through your website is that actually on your About Us page, there's kind of Bar from Monte Carlo, who's, I don't know, in an advisory role, whatever. I'm actually super curious, is how does a tool like Monte Carlo kind of compare, which is also a lot about data quality, data observability, right? Is to me, I'm a database internals guy who builds database systems. So this part is always super interesting to me. And I'm not sure I 100% get it yet, to be honest.
So a tool like Monte Carlo, let me use a metaphor. If you think of the software engineering governance or quality stack, right? We don't really talk about software in terms of having governance and having quality systems, but they exist. GitHub is a change management system for code, right? That's really all it is. People are making changes to their code base, and all the different functionality of pull requests or merge requests, or looking at the various code diffs, or being able to comment on those various PRs, or even the act of merging and branching in and of itself, is just a mechanism to manage change easier. And you need something like that. Otherwise, you don't have an audit log of how code has changed over time. You don't have a way for humans to easily insert themselves into the review process while you're trying to manage an agile, constantly evolving code base. So that's sort of one pillar of this three triangulate of quality and governance. The second pillar is your monitoring. So these are tools like Datadog, right? You have checks looking at the actual, what are customers actually doing in your application, HTTP requests and errors and things like that. And if you detect something that's wrong, usually the engineer, so the producer who's ultimately responsible for customer outcomes, will go and debug those changes and use the data from Datadog to handle that. And then the third component is you need some mechanism of collaboration and documentation, and what does this data mean, and or what does this code mean, and where is it found, and what does it do? And those are your tools like Jira or Confluent that are effectively catalogs, right? They're catalogs of information about your software. So you've got the change management system, which is GitHub, the quality and monitoring system, which is Datadog, and the information repository, which is Confluent and Jira and things like that. And so you can imagine that same sort of triumvirate in the data space as well, but the needs of data teams are different than software engineering teams. Data teams don't just care about how changes, usually when you think about a change in code, it's one software engineer working with another software engineer on their team, right? I'm updating my repo, you understand my code base, so I want you to look at my code. But in the data space, that can't be the case, right? If I'm a data scientist, usually I'm going to be impacted by someone else making change in a very different part of the organization. So change management has to not be within a team, it has to be across teams. And that's sort of the unique role that Gable fills, is we are looking at code, understanding when changes happen to data specifically, and then understanding what the impact of those changes are going to be on the teams who ultimately use that data for some meaningful purpose. Whereas Monte Carlo fills more of that Datadog role, which is looking at the contents of the data itself and helping engineers debug when things go wrong. And of course, you have data catalogs, and data catalogs are sort of your Jira Confluent equivalent, if that all makes sense.
So maybe in some sense, a Monte Carlo comes after the change, and it's too late. So yes, it's a barrier to protect you and tell you your data quality might be at risk, but it's not a data quality issue at all. It's a chain reaction that started with a PR by an engineer writing Java. That was kind of propagated down the chain. Eventually, somehow, there was an error coming back from Datadog, and now you need Jira and all the tools that Chad just described, 5 tools, 4 at least, if I remember right, different roles to figure it out, that there is a connection between that PR and that error coming back from Datadog. And yes, the data quality is wrong, but not necessarily. I think I get it now.
Exactly. What you just described is this is the problem that I think so many software engineers don't understand. Because in their world, if you have a bug is something that is very deterministic, right? Like I have a set of requirements for my code. And if those requirements are no longer met by the code, that is a bug. And now I need to, I can run tests on it. I can go root cause it. It goes to my incident management system and so on and so forth. But in data world, you might have a producer of code do something that makes complete sense for their use case, right? Maybe I have a timestamp field and I want to change that from local time to UTC. Makes sense. That's probably what you should be doing. But if somewhere downstream, a data scientist has built a machine learning model that has some, the timestamp field has some sort of predictive weight to it, those predictions will be wrong if they're not informed that that change is coming and update their model accordingly. So you can create data quality issues from changes that are good. And that is a very different, that's a very different sort of concept than most software teams are familiar with.
Gotcha. So that was, I think, a really, really good, like kind of top-down bird's eye view explanation of the space, right? And I appreciate that. So for me as well, like it makes a lot more sense now. Maybe another way to approach this is actually like a bit more bottom up, right? Say I'm the software engineer, I own a repository, I publish some messages to Kafka as part of that. And like somewhere far downstream in the organization, there's a data science team which also builds a predictor on that. I make a code change now, and I make that code change that goes from, let's stick with your example, kind of local time to UTC. Like, will my CI fail? Like, what's actually like, what does Gable do then in order to alert me, hey, like, you're gonna cause some damage here, right? It's like, how can I imagine, like, how does it impact my life cycle as a developer, basically?
So the way that we think about it is that my intent with Gable is to ultimately sort of light the spark of culture change in a company, which is a very lofty vision, but that is ultimately the goal. And what my belief
I love this vision. It's a great vision. It's an ambitious, great vision. We've been doing the Jira things for 30 years.
Yes, exactly. The real high level question is, how do you change the culture of how teams think about data, use data, all these types of second order effects? And my view is, I believe in this very strongly in this concept of Conway's Law, if you're familiar with it. And Conway's Law essentially says that the way people, the systems people use to collaborate with each other and talk within an organization is ultimately reflected in their architecture and their systems and their processes and the product itself. And in the data space, you think about how people talk to each other. Well, you've got these producers and consumers that are the two primary sides of the data equation. You could argue that there's platform teams and sort of data engineers in the middle. We're not very good at talking to each other. And that's because of all the problems I laid out before. There's this missing translation layer that's not actually helping each team understand the context of what they need to know in order to make a good decision. So we sort of rooted in that, right? Which is, what is the right information to share with the right person at the right time depending on the change that's happening. And then what you do about that with all that information is sort of the next set of problems to be solved. So now that we understand that, I'll kind of drill down and make it very tactical.
Okay, so quick question. So the problem exists everywhere. Every every company that builds software to deliver value to customer goes through that challenge. And then over many cycles, like the only solution that was available for everyone was build a global semantic model. It solves maybe a third of the problem, but let's get everyone, those different cultures, those different well-deserved opinions, because as you said, those are different environments ran by different cultures, different team, different purposes that needs to be combined together to provide customer value. And the only thing we could do is just kind of bend reality, which is build a global semantic model so everyone talks the same language. That doesn't work. You just can't enforce that single Latin language on everybody just to kind of try to solve that problem. And my question is, how do we replace those semantic models, which obviously are very challenging, and they do solve many problems, by the way. Vertical, right? If you do drill downs, yes, you can solve a lot of problems with semantic models, but it doesn't solve the problem that you are talking about. How is AI coming in to change the equation, right? Because this is the big change. Going from a semantic, human-managed, project management kind of mindset to a AI mindset. And this is super interesting. So tell us kind of how is that change happening and what is happening there?
You're hitting on all the points. So yeah, to maybe answer the first part, or to not answer, but follow on the first part of your statement, which is, we had this concept of a semantic layer, or this large semantic model, and the entire business would agree on what certain terms were and how to use them. And then anyone who is writing a query in the future or generating data that sort of corresponds to those terms would need to follow all these. Of course, the challenge there is that works reasonably well if you have an incredibly centralized data production and consumption organization. Meaning I cannot create a new database without going through some centralized body that has the context of all this semantic information and can make sure I'm doing it the right way. And I cannot build new data pipelines without following a similar process, right? So it is that steward in the middle that is keeping the map, the semantic map of the world in their head and requiring enforcement in all these different places. That becomes a lot harder to do in this modern era of the cloud that is totally decentralized bidirectionally, right? You have software engineers that are encouraged to move as fast as possible, build microservices, solve customer problems, right? Go fast, ship things. And then on the consumer side, now that you've got tools like dbt that are effectively federating out data modeling, you've got a lot of analytics engineers and data scientists who are building their own data models, and you start to see the warehouse sort of expand out this way as well, right? So that makes the maintenance of a semantic layer very challenging. Who is even doing that work? Is it the central team? Is it your central governance team? It just becomes very, very hard. The amount of change radically exceeds the effort. The effort to maintain the system radically exceeds the amount of resources you have to do it. So that's the current state of the world. So what does the world actually need to look like? At least, again, this is my opinion. But what I think is that the people on either end of that process, the producer and the consumer, have all of the context that they need in their head, and they reflect that context through the code that they write, right? So if I'm a software engineer and I am building a service that is collecting customer data, which I then use to populate a UI, a reasonable software engineer, like a mid-level software engineer, would be able to look at that code with a little bit of context, maybe from documentation, and infer what's going on, right? Like, I know this is a website front end. I know that someone is clicking on a button to sign up for my website, and I can see that creates a new record in my database, right? Like you can do that. And then on the other side, a reasonable person can look at a SQL query and they can look at the names of the columns that are being joined together and come up with a reasonable idea of like, what is the output this is supposed to be generating? And of course, there's a lot of context around that as well, like the actual dashboard and documentation and yada, yada, yada. And what my view, where AI fits in all of this is that those types of things, looking at code to infer intent, is exactly what AI is extremely good at. Like that's one of the main things that it's good at, actually. There's a lot of things it's not that good at, but that, like extracting semantics from code by following convention and patterns, it actually is really good at. So the question is, how do you leverage AI in order to extract that meaning from both sides and then effectively manage the translation in between what is created and ultimately what is used? I think that is the problem to be solved. And there's some sophisticated ways that you can do that, but this is really at the core of what Gable is. Sorry if that was a very long-winded explanation.
I loved it. It was perfect. So quick follow-up question on that. How do you educate your customers and prospects and the market, which already spent years, right, building a physical semantic layer of people, ownership, departments, you've mentioned centralized. So many companies, so many teams had to resort to a centralized semantic or middle like a gate, right? It's always kind of a cultural thing. Every company goes through that. They start decentralized, and then a subset of that ends up centralized because of all of those challenges, and then they give up. So they apply people, manual processes on that kind of state. Now we're saying we don't need to continue and invest and keep that state going. We can actually start dissolving it slowly and carefully and figure out how people that are involved today in keeping up that process going, what are they going to do and how? And how is what's the transition going to look like for them? That's is an equal of a challenge to solving it technically, because once you solve it technically, you deal with the human challenge, right?
Exactly. I think that is you're exactly right. So there's a few interesting things. The first interesting thing is I don't think that the way any of this can work is to take an LLM and to throw it at the problem and say, go do magic, right? That it doesn't work like that for a lot of different reasons. One reason being, at least the current state of AI, and this will improve over time, certainly. But in the current state of AI, these models do not do a very good job retaining memory. Their state management is quite bad. And especially when it comes to the analysis of code, state management is like kind of important. It's actually extremely important. If a function takes, two values, I need to guarantee that anytime that function is used, it's taking the same, two values effectively. And and the AI is effectively guessing at what the function takes and what the values are, because it doesn't really have a concept of state management today. And there's a bunch of other reasons where if the context windows are big, then the cost is just insanely massive. And so trying to reason over all this stuff all the time becomes exorbitantly expensive, yada, yada, yada. Anyway, point being is that what makes this problem a lot easier for a model to go and solve is when it's directed, right? When you can give it context and help and hints about how it should be doing interpretation, you're shrinking that context window and you're making it a much more powerful and scalable system. And that applies not only to, what code should it be looking at in order to infer, what is this data and where is it being used? That's sort of a challenge in and of itself. But also you have, like you said, you have all this existing context and existing work that's been done that can make these models so much better. And the more context you add over time, the smarter the models actually become and the more effective they become at doing the tasks. So I think there is this transitionary period where the people that are currently spending all their time managing these massive ontologies will gradually transition to saying, how can I teach the model about everything that I've built over the past 10 years or 15 years or whatever it is? And that's not going to happen in a day or in 2 days. It's going to take time. I like to think about AI, at least a relatively basic untrained AI, almost as a new intern to your company, right? Like, it's not that great at its job, but it can be in many different places at once. It's almost like a universal intern, like an intern that's just everywhere, like an omniscient.
We love interns.
Yes. And so the question is, it's probably not useful for that system to remain an intern forever. And it could end up costing a lot more than it's worth if that's the level. So you have to raise the knowledge and raise the awareness and the value of that intern. I think that only comes through these more manual, human in the loop steps. And I think that what that actually does, people sort of get very scared of AI, but frankly, I think what it does is that it allows the data team and the data engineering organization to transition to the work that's actually interesting and useful, right? Instead of constantly trying to keep track of the semantic state of the world, you start thinking about strategy. How should we be keeping track of things, right? How do we want to orient our business? How do these various teams sort of start to take a semantic concept that's been defined over here and merge it with another semantic concept that's defined over here, right? This is the types of problems they'll begin working on.
So for most information workers today, AI, they mostly consume it, right? They consume a model. It's kind of a black box for them. One of the challenges is, and I completely relate to what you're saying, is how do we take all of the information workers and their value is their context that they have. This is something no system can take away from them. They apply, as you said, they have applied the same context previously on software to build stuff. Now you're saying we will start transitioning away from that into teaching models, into building interfaces so information workers can provide context back. That will not necessarily be a diagram or an input box, I don't know, but there needs to be some interface allowing information workers to feed the model back. And this is like absolutely waiting for disruption because, right, the model is a black box. It's being handled by very few people who know how to generate it. And everyone else, which is 99% of the information workers, are basically kept out of it. They don't know how to tell the model, how to give it, I don't know, hints, context, background, data points. They do it on legacy tools all the time. So they know how to do it. We know how to provide context. Just have someone just build those tools to help us do it. And once you get those interns, start interns. We are all interns in my example, right? In that case, if you give us the tools to provide context to the model, to the AI, versus the legacy tools, then actually I think like that's gonna happen. That's everything connects. At least to me, everything connects, and it makes perfect sense.
I think you're exactly right. One of the fascinating things that I found is in this space, it's much less about building a technology, although we do have to do that, right? And building the technology is very hard. And we've had to hire, PhD researchers and folks who've worked in code analysis for many, many years. And like, that's very, very challenging. But it's not really about the technology. It's more a question of incentives. How do I get the people? There is some information I need to extract from various people along this workflow. And then there's certain changes in behavior I need to inspire. So how do I create the right incentives so that A, I'm getting all the data that I need, and B, how do I sort of initiate a change in the culture? And I think there's a lot of interesting ways to do this. So on the consumer side, one of the best incentives is if you provide context to the system about what does the data mean? What do you care about? What indicates a data quality issue? How should the world actually look? Which, to your point, an LLM will never know that. It will never have all that information. A person will. Well, if you provide that information, then you get high quality data back, right? It's a feedback loop. So if you want to productionize some data product that you have created. And that could be a machine learning model. It could be, I have a report that I send to the CMO, and if it's wrong, they come and chew me out on a Friday. Or this is actually public information that goes to the board, or whatever it is, right? If you want that data to be right, and you want there to be very clear, explicit ownership and thoughtfulness around your use case, then you need to provide the context of what you need, which sounds like a very basic and obvious idea, but it's not something that has really happened generically. It's certainly not through vendors and platforms in the data space. And on the other side, on the producer side, there's also an incentive, right? This is where I see most, especially data folks in particular, will give me this feedback and say, well, my data producers don't care about me. They don't care about data. They are not interested in changing their work or taking on more work that makes my life better. I don't think that's actually true, not based on the thousands of conversations I've actually had with software engineers. What they usually say is, you need to make, number one, you need to make it easy for me, right? If I have to go and own a bunch of technologies and systems that I have no knowledge of and no experience around, I need to own data quality tools. I need to look at a data catalog and figure that whole thing out. I need to own DBT. I need to own testing and validation systems inside of, whatever your analytical database is. They're like, yeah, I'm not going to do that. Like I have enough work on my plate just dealing with the systems I'm maintaining today. So you have to make it very, very easy. The second thing is they need the context, like what we've been talking about. They should understand it. Where is the data that I'm producing going? Who is using it? What are they using it for? Is it important? How important is it? Right? And then there's the expectations. So what is expected of me? What is expected of the data? And how would I know if those expectations are not being met? Right? And then even after all of that, there are going to be situations where you might have to change the data in a way that does objectively cause problems for a downstream consumer. But there should be a workflow around handling that, right? If I'm making a breaking change to someone, the problem is not the breaking change. The problem is the time between when I make the breaking change and when it actually affects that consumer's query or dashboard or whatever it is. And so if you can create the right systems that are incentivizing the producers to say, oh, I know who my consumers are. I know how they're using this data. I know that this thing that I'm doing is going to affect them. I know how it will affect them. I know who I need to communicate to at what point in time. Then it's much easier for them to follow that process than deal with all the fallout of trying to fix an issue they shipped to production 3 weeks ago.
Right. So at this point, I'd actually love to drill down again and return to this previous conversation, because I think it's a natural kind of, here it connects, right? I make that PR, I kind of change from local time to UTC. How do I interface with a tool like Gable? Now, both on the producer side and on the consumer side, who have to then maybe, once I make the change, adapt to it.
Yes. So this goes back to the sort of 3 layers of technology that I mentioned in the beginning. And I think to your point now, let's maybe drill down to another layer. The first step, and I think the lowest level of maturity in this big cultural change we're talking about, is you just have to know what data is being produced where in your code base. So what Gable does is we have a command line interface. You can point it at essentially your all the repos in your company. We know how to scan that production code, and we can essentially identify where there is data being emitted and pushed from one system to another. Once we can identify that point in code, we can reverse engineer the payload. So we can say, all right, we know that this is the actual event payload, this is the schema, and we also have a code block that contains all the surrounding context of that particular event, which you can feed into an AI system and ask it, hey, what exactly does all this stuff do? Once you've defined all that, so that is stored within the Gable UI and the Gable APIs, we run as a part of CI/CD. So anytime there's a new PR that gets opened, we understand what the state of the world should be. We take the diff into what the new state of the world is, and we also understand, are those changes going to cause this data object to meaningfully be altered in some way, right? And those changes alone, as long as we know who is using that data, and there's a whole other explanation on how we know that, we can communicate that information in the language that they understand, which is English or whatever language it is you speak in your part of the world, right? Hey, this change is coming. This is how the data will be different from the previous version to the new version. And this is how it affects you. And we know that because we know sort of how it's all connected and we can trace it, right? So that's kind of like level one, is you're just tracking how changes occur and you stick that into an audit log. And so if you want to do root causing and say, hey, I want to understand how my data has changed over the last 6 months, well, you've now tracked everything and you have all the context.
I guess these layers also connect to then how you can over time gain wider adoption within an organization, right? Because I could still at this point have my like semantic model and all of these things and my higher level concept. And I just use Gable in this like layer one kind of for, hey, wow, okay, now something went wrong and understanding the root cause, for example, or what upstream change caused that.
Exactly. A very common sort of first use case for Gable that we see is someone will say, hey, I've got some data coming from my production system that is really important to me. It might be data that I sell to a customer. It might be something that feeds into a machine learning model that makes me $100 million a year. It might be data that feeds into our accounting system. And I need that to be right. And I need to know anytime that changes, and I can't be reactive. I have to be proactive in how I sort of deal with that and track it over time. So that's sort of layer number one. The second layer is you're starting to give feedback to the engineers making the changes of how what they're doing impacts the rest of the system. And you do this with data contracts. So the way that I like to think about the contract is that it is a baseline that represents the expected state of the world for data, right? So as long as someone has said, hey, this is the way that I always expect the data to look. If there is some code change that happens that causes that data, that causes that state of the world to be different, you can give that feedback directly to the engineer through a comment in the pull request. You are making a change. Here is how you are changing the state of the world. Here is the people who are dependent on that state of the world being true. And here is all the negative downstream impacts that this change is going to have if you make it without giving them some leeway or whatever it is, right? Level 3 is, all right, now that we all understand the role that we play in this ecosystem, right? You as the producer know how you impact me as a consumer. Then we start rolling out, this is the governance as code, right? We're building integration tests so that if the contract is not being followed through a code change, you simply can't make that deployment. And you either have to update your code or update the contract, which has its own approval workflow. So the people who are dependent on the contract will need to say, okay, I understand that this change to the contract is coming. I need to reflect that in all of my queries and so on and so forth, right? So this is sort of tactically how that change sort of manifests over time.
Nice. Super, super cool. This was incredibly interesting. Seriously, it's like such a cool take on organizing kind of data and at scale. Seriously. So looking at 2025, right? Like I think once the episode goes live, maybe it's in January already, is like, what are you excited about for Gable? Like, what are your goals for 2025? What do you hope to achieve?
Oh yeah, that's a good question. So the thing that I think is most exciting to me is to continue to see ways that our customers use a system like this, right? It is extremely flexible and varied. We have seen folks who have not just started using it for the benefit of their data engineering organization, but are also using it to manage the relationship between front-end engineers and back-end engineers for changes to APIs. It's all just data at the end of the day, right? And so if you could say, hey, back-end engineer, you're making a change to the API that I'm consuming to populate all these UI components, that is going to affect me. Now you're starting to make this data management problem something that the engineering organization cares about independent of ML and data engineering and analytics. And that is really what you want, right? When the whole company starts to care about data from their perspective, and they start to care about how changes made to data affect other people. And, I think the word data mesh has, there's a lot of like, people have done a ton of writing about it. Jamak is amazing. I think data mesh is a very, very beautiful idea. But I think that there's actually something that's a little bit more foundational than data mesh, in my opinion, which is just the concept that if you're building software systems, you can never truly decouple yourself. You are always tightly coupled to something. And the previous state of the world has almost been a lie, in my opinion. It's almost like, let's just kind of pretend that we're not tightly coupled to anything, and let's build almost independently of the broader system. What would be really exciting for me in 2025 is this broader realization that actually everything is a mesh. Any software is actually a mesh. And as a company grows, the mesh gets more and more sophisticated. And the next stage of software management and data management is, how do we exist within the mesh? And there's a lot of other features and functionality and use cases that you can start to think about, and that Gable will ultimately support in that world.
Nice. I love that as like a 2025 goal. How do we exist in the mesh? That's an awesome closing sentence, Chad. Thank you so much for being part of the show. Really, it was great having you. And all the best for 2025.
Thanks, guys. This has been really fun.
Thank you.
The Data Engineering Show is brought to you by FIREBOLT, the cloud data warehouse for low latency analytics. Get $200 credits and start your free trial at firebolt.io.